All right, welcome to the last example. In the last example, what we're going to do is we're actually going to have to find our own u and v. We're going to actually find, what we're going to substitute for u and v. And so we're given this region that's bounded by y equals 2x minus 1, y equals 2x plus 1, and y equals 1 minus x, and y equals 3 minus x. Now, when I'm asking you to do this, it's not going to be a very difficult problem for you to do, because what you're really looking for is, okay, we want to find where we make u and v, that when we substitute these into our equations, that we're going to get constants. So that's what we're always looking for. So for this first one, what we're going to do is we're just going to go ahead and we're going to plug in we're going to transform y equals 2x minus 1 to be y minus 2x equals negative 1. We're going to change the second equation to y minus 2x equals positive 1. The third equation to y plus x equals 1. And y plus x equals 3. And then this will help me define, okay, what we can make our equations. Now, again, there are going to be many different ways that you can transform these, all right? But, this is the easiest way and probably the first way that you would do it. So y minus 2x equals negative 1. We can say, oh, well, let's just go ahead and say, since they're both y minus 2x, let's say u is y minus 2x. So u is equal to y minus 2x. That will take care of, so when we substitute in, we're going to get, that would be u equals negative 1 and u equals 1. So u is going to be between negative 1 and 1. So that's why we chose u is equal to y minus 2x. And then to take care of the other boundaries, y plus x, we can say, well, let's just go ahead and make v equal to y plus x. If we do that, then v is equal to 1 and v is equal to, let's just write that out, v is equal to 1 and v is equal to 3. And now we can help define our region. All right, the last thing that we need to do and we need to take care of is making sure that we know how to go from u to y and x and v to y and x, but how do we go from x to u and v? To do that, and again, this isn't going to take too long to do, but in order to do this, what we're going to do is we're going to take our u's and v's, and we want to either add or subtract to get rid of one of our variables. So it looks like I can take, I can get rid of y pretty easily. I just do u minus v. If I do u minus v, that's going to be y minus 2x minus y plus x. I'm going to get rid of the y's, which I want, and I'm going to be able to solve for x. So I'm going to have u minus v is equal to, make sure that I put that in parentheses, negative 3x. And what I can do is I can, let's get rid of the negative because we don't really want the negative there. So we can say, well, u minus v is also just v minus u is equal to 3x. So we just got rid of the negative there by stripping a negative through. And so really x is equal to 1/3 v minus u. So now we solved for x. Do the same thing for y. All right, now we want to get rid of a y. Let's go ahead and to get rid of an x, we can just subtract 2x from, so we can say u minus 2v. That way we get a 2 there, and we're subtracting, actually let's add, because we want to get rid of that negative, so we're going to add. So I'm going to go ahead and get rid of that little 2 there. So what you can see, so u plus 2v is going to be y minus 2x plus 2 times y plus x. When we do that, we're going to get 3y, the x's cancel out, is equal to u plus 2v. So then we can say y is equal to 1/3 u plus 2v. And there we go. We transformed it. We found our x's, we found our y's in terms of uv, and then we also found our u and v in terms of y and x. And again, I'm not going to give you any that's going to be overly difficult, but anytime you want to find, okay, what should u and v be? Always find to where when you plug in u and v, you're going to get those constants for your region. All right, and so it's going to change what, originally all this was a parallelogram. It's going to turn it into just a rectangle. All right, the last part, we're just going to go ahead and integrate using our values, so the double integral, but of 3x plus 3y of this region. So we're just going to go ahead and say, okay, let's go, let's do u first, and so u goes between -1 and +1. The second integral goes from 1 to 3 for v. 3x plus 3y, I'll go ahead and just do a substitution of that real quick. It's going to be 3 times 1/3 v minus u plus 3 times 1/3 u plus 2v. So the 1/3s are going to cancel out with the 3's, and so we have v minus u plus u plus 2v. And so I just want to make sure that everything I'm doing is correct. So we'll have 3v, and then looks like we'll just have 3v, if I'm not mistaken. Again, I just want to double check to make sure that everything is good. All right, v plus 2v is good, and then negative, yeah. So we're at 3v, and then we'll do 1 to 3 was v, correct? Yeah, dv, du. Do not forget the Jacobian. So the Jacobian goes here. So let's find the Jacobian. So the Jacobian is going to be the partial of x, y over the partial of uv. So it's just the determinant. The partial of x with respect to y, or with respect to u first, is -1/3. All right, and then the partial of x with respect to v is just going to be +1/3. The partial of y with respect to u is going to be 1/3. And the partial of y with respect to v is going to be I'm sorry, for some reason just forget what we're, it's going to be 2/3. All right, partial of y with respect to v is 2/3. All right, let's go ahead and cross multiply. So we're going to get -2/9 minus 1/9, and that's going to give us -3/9 or -1/3. But the Jacobian's always going to be positive, and so it's the absolute value of the Jacobian. So that's why we have like the absolute value there. So it's going to be, that's why we have absolute value there. So it's the absolute value of -1/3, which is just 1/3. Which is nice. That's going to cancel out that v, so we're just -1 to 1, 1 to 3, v, dv, du. And we can break that up to be -1 to 1, du times 1 to 3, went ahead and did it, v dv, and row that's just going to be u from 1 to -1 times 1/2 v squared, 1 to 3, and so doing that, we're going to get 1 plus 1, which is 2 for the first, and then the second, we're going to get 3 squared, so 9/2 minus 1 squared over 2, so 1/2. So that's going to go ahead and give us 9 minus 1 is 8, so 4 times 2, which is just 8. there we go for a double integral.